All right, here is part 2 of 5.4, multiplying polynomials. Okay, so let's go ahead and take notes. 5.4, this is part 2 of 2. Okay, so we are continuing with multiplying polynomials. And what we're going to look at here are some special products. Okay, so these are nice because then you don't have to deal with all that distributing. You go straight to the answer. Okay, so, but before we do, let's just kind of recall multiplying binomials with another binomial. And then also exponents. Okay, so let's just kind of recall what this means. So here, again, we have the grouping symbols. And so the base for this exponent is everything inside the parentheses, which is 3x plus 2. And so what this really means is 3x plus 2 times 3x plus 2, right? That's what that means. And we can use what we learned in part 1 of 5.4, distributing, right? And if we do that, we get 3x times 3x, that's 9x squared. 3x times 2, that's 6x. And then distribute the 2 now, so 2 times 3 is 6x. And then 2 times 2 is 4. Okay? And when we combine like terms, the 2 in the middle, I get 9x squared. And here I combine 6x and 6x. And I get this for my answer. Okay. Let's just go ahead and take a look at another example of this. So, and let's see if we could find some patterns. Okay. So let's do one like this with subtraction. Okay, so let's take a look at 2x minus 5, quantity squared. And so again, the base is everything that's grouped inside the parentheses. So the base is 2x minus 5. So this means 2x minus 5 times 2x minus 5. Okay? And again, if I distribute the 2x, I get 4x squared. And then 2x times negative 5, that's negative 10x. And then I go inside here, distribute the negative 5, I get negative 10x. And negative 5 times negative 5 is positive 25. Combining like terms, the ones in the middle, I get negative 20x plus 25. Okay. So what's happening here is, if we notice, the two terms in the middle seem to be the same, right? 6x and 6x, negative 10 and negative 10. Okay, so that's one pattern that kind of stands out. Okay, and then in relation to this, we see, 3x times 3x, that's 9x squared. 2 times 2 is 4. So same thing here. 2x times 2x is 4x squared. 5 times 5 is 25. Okay, so we notice here that in our final answer, the terms on the end are perfect squares. And they're the perfect squares of the two terms here, 3x and 2. 9x squared, 4. 2x and 5. We get 2x squared and 25. So we see the terms on the ends are the perfect squares of the terms that are here. Okay, so let's take a look at the middle terms. So we see here that they end up being the same, and we end up combining them. They end up being the same, and we combine them. Okay, so if you notice, these terms are the product of these in here. 2 times 3x is 6x. 2x times negative 5 is negative 10x. And we have two of them. Two of them. Okay, so that's a pattern. So we see here that the pattern is that we have this one squared. We have this one squared on the other end. And for the middle, it's their product, and we have two of them. Okay, so let's take a look. Let's take a look at this example. And let's see if that's true. Okay, so let's take a look at 4x minus 3 quantity squared. Okay, so according to what we just noticed, we'll have a trinomial for our answer, right? And it turns out that here, this first term will be this one squared. So that would be 16x squared. And this term would be this one squared. So that would be 9 plus 9. Okay, and we said that the middle term is going to be their product, and we'll have two of them, negative 12x. So it's going to be like the negative 12x and another negative 12x, right? The two terms in the middle that combine. And so that would give us negative 24x. Well, let's see if that's true. Okay, so again, we got this squaring the 4x. We got this one from squaring the 3. And we got this because it's their product and we have two of them. Okay, according to the patterns that we noticed in these two examples up here. Okay, we said, okay, so in the trinomial, we square that. The last term, we square that. And this middle term is their product, 6x, and we have two of them. Same thing here. We square that, and this is going to be negative 10x and negative 10x. So let's check. So if I do 4x minus 3 times 4x minus 3, okay, so distributing the 4x, I get 16x squared minus 12x. And then if I distribute this negative 3, I get negative 12x plus 9. So I get 16x squared minus 24x plus 9, which is exactly what we got here. Okay, so in general, when we are squaring binomials, we kind of have this formula here. So here, I'm just going to write this funny x to mean, it could be a term like 5x or it could be 2m. But whatever that first term is, plus whatever this term is, it's funny looking y. Okay, and again, that y could be a 3n or a 5b. Okay, but when you square this binomial, it turns out that, oh, okay, so this is just going to end up being a trinomial where you square that first term, and down here, you're going to go ahead and square that second term. And then for the middle, we're going to get xy twice, right? So we're going to get this product, but we're going to get it twice, right? Just like we saw here. We saw that we got the negative 12x, negative 12x, that product, okay? And same thing here, negative 10x, negative 10x. It always appears twice, 6x, 6x, and it happens twice, okay? So we have their product, xy, and it happens twice. Okay, and if it's subtraction, it's very similar. So we have x squared there, and we square that one there, and we still have their product. We have their product, and it appears twice. The only thing that's different is that their product is negative. Okay. So this would be a good thing for you to memorize so that when you take higher levels of math, and when you get into the other sections, you don't have to deal with distributing this, writing it out, distributing the 2x, distributing the -5, and then combining like terms. As soon as you see this, structure, you can go straight to this trinomial. Okay, and again, those trinomials, you square that term, take their product, and it appears twice, and then you square that term. Okay, so let's see. Go ahead and see if you can do this one. 6x minus 5 quantity squared. Try to see if you can figure out what the trinomial would be. Okay, so go ahead and hit the pause button and come right back. Okay, so this first term is 6x squared, so that's going to be 36x squared. This last term is going to be 5 times 5, so that's going to be 25. It's always positive. And the middle term is going to be their product, so that's negative 30x, but we have two of them. So negative 30x is negative 60x. Okay, so you should have gotten this for your trinomial. Okay, let's just try one more in case you did miss that one. Okay, let's do this one. 7x plus 2 quantity squared. Okay, so go ahead and find the three terms and hit the pause button. Okay, first term is going to be 49x squared. Last term is going to be positive 4. And then it's 14x and 14x, making it 28x for the middle. Okay, so hopefully you got this, 49x squared plus 28x plus 4. Okay, so now let's go ahead and take a look at evaluating functions, and let's see how this will be a nice little shortcut for us. Okay, evaluating. If you ever forget the shortcut, you could always just do the distributive property and then combine like terms. Okay, so let's just recall how to evaluate functions. So if you have this function, f of x equals x squared plus 9x minus 5, and you are asked to find f of 2, okay, so again, that doesn't mean multiply by 2, that means evaluate at 2, which means you need to replace all the x's with 2. So 2 squared plus 9 times 2 minus 5. Okay, and that will give me 4 plus 18 minus 5. That will give me 22 minus 5. And that will give me 17. So f of 2, that's how we read this, f of 2 equals 17. Okay, so that was before. So now you might be asked to find something like f of a plus 4 using that same function. So let me scroll so you can see it. So if we're using this function, this means I need to replace the x's with a plus 4. Okay, so make sure you use parentheses. So it's going to be a plus 4 squared plus 9 times a plus 4 minus 5. Okay, all I did was right here, I replaced all of the x's with a plus 4. So a plus 4 goes here, a plus 4 squared, that's how I got that, plus 9 times a plus 4, that's how I got that, and then bring down the minus 5. Okay, so here's where that little shortcut comes in handy. So from what we just did previously, this is going to be a trinomial, right? It's going to be a squared here, 16 here, positive. And then over here, it's going to be 4a and 4a, making it 8a. And then here, distribute the 9. So I get 9a plus 36. Okay. And then you can combine like terms. So that's a squared. 8a and 9a, that's 17a. And over here, let's see, 16, 36 minus 5, 47. Okay. All right, so this would be our answer. But here, so you can see how this kind of knocks off a couple of steps. So we can go straight from this to our trinomial. Again, our trinomial is we square that, and the middle, it's their product, and it appears twice, 4a and 4a. Okay? And it's plus because it's plus. Okay, let's see. Why don't you try this? Here's your function. And I want you to find f of a minus 8. So you're going to replace all the x's here with a minus 8. Okay, so go ahead and hit the pause button, and let's see if you guys come up with the same answer. Okay, so the answer, you should have gotten a squared minus 22a plus 113. Okay, so this is the answer you should have gotten. If you didn't get that, then watch how this gets worked out. All right, so f of a minus 8. All right, so I have to replace all of the x's. So I have to replace this x with a minus 8 and this one with a minus 8. All right, so it's a minus 8 squared minus 6 times a minus 8, and then plus 1. Using my shortcut that I just learned about squaring binomials, okay, I'm going to get this trinomial. This one's going to be a squared. This one's going to be positive 64. And remember, the middle term is going to be 8a, and it happens twice. Negative 8a, negative 8a is negative 16a. All right. And then I'm going to distribute negative 6. So I get negative 6a plus 48 plus 1. Okay. So I get a squared, negative 16a, and negative 6a is negative 22a. And then 64, 65 plus 48 is 113. Okay, so that's how we get that answer. Okay. And for a really complex problem, let's see if you can get this one. And then we'll end here. Okay. See if you can simplify this. So you have this scoring a binomial, and then you'll have this subtraction. Careful, because you're going to have to distribute that subtraction once you finish this multiplication. Okay, this is about as hard as they get. So if you can get this one, then you're golden. Okay, so go ahead and give it a try. Hit the pause button. Okay, so here's the answer. If you got this, 24x squared minus 34x plus 23, then you are golden. Okay, so if you didn't, then follow along. Okay, let's go ahead and square this binomial. When you square that binomial, you're going to get a trinomial. It's going to be 25x squared here, positive 16 here. In the middle, it's going to be negative 20x and negative 20x, making a negative 40x. Okay? Here, so I get that for my first answer. Then I'm going to have this subtraction. And I'm going to, this one I have to work out the long way. X times x is x squared. X times 1 is x. Negative 7 times x is negative 7x. Negative 7 times 1 is negative 7. Okay, so these guys are still waiting. And here I can combine like terms, x squared, negative 6x minus 7. Okay, so now I can distribute the subtraction. So you guys can come out of your parentheses. This gets distributed, so that becomes negative x squared. This becomes positive 6x, and this becomes positive 7. And then combining like terms, 25x squared minus 1x squared, 24x squared. Negative 40x plus 6x is negative 34x. And 16 plus 7 is 23. And we see that's what we got up here. Okay. All right, so that is it. If you have any questions, make sure you message me. Keep up with the homework, you guys. I'll see you next time.